As more research emerges about the efficacy of online learning, it becomes increasingly clear that course design must conform to context. A recent study by Devayan Debashis of Iowa State University's Department of Aerospace Engineering investigated the outcomes of an online introductory engineering course versus a face-to-face equivalent. The study, titled Comparison of Academic Performance of Students in Online versus Traditional Engineering Course, appeared in the European Journal of Open Distance and E-Learning this month. For eLearning Inside, my name is Henry Kronk. This week on Ed Technically, we're going to take a look at this study, see what it has to say, and talk about the conclusions that it draws. The study investigated a Mechanics of Materials summer course, which is a required introductory engineering course at ISU. For the first time that year, in 2016, an online version was developed and ran simultaneously with a face-to-face version. Multiple issues are at stake with this study, and it also had certain unique indicators as well. Introductory undergraduate courses across fields of study are consistently challenging for faculty departments. They typically draw in large volumes of students. When the time comes to find room in the budget, furthermore, it's often possible to reduce costs easily by increasing class sizes and paying fewer instructors. It is unfortunately well established that this, if pushed far enough, leads to poor academic achievement. Beer defines a large class as above 40 students and cites previous research that shows that increased introductory class sizes lead to numerous negative outcomes. These include worse academic performance, lower levels of creativity, less engagement between instructor and students, lower quality of instruction, and lower overall student satisfaction. What's more, the volume of engineering undergrad enrollments has risen steadily since 2005. So even if institutions have managed to maintain the number of engineering courses over this period, they have still grown more crowded. It's not uncommon for an introductory class to be so big that a single lecture hall cannot accommodate it. In that case, students often sit in a separate lecture hall where a live stream of the lecture is being projected. All of these qualities are obviously less than ideal, and online courses pose a potential solution to possibly every one of them when it comes to these huge introductory lectures. What's more, some respected research supports this conclusion. The U.S. Department of Education conducted a wide-ranging meta-analysis of research on online learning between 1996 and 2008. As Beer quotes in his article, the study found, quote, students in online conditions performed modestly better on average than those learning the same material through traditional face-to-face instruction. The effectiveness of online learning approaches appears quite broad across different content and learner types. Online learning appeared to be an effective option for both undergraduates and for graduate students and professionals in a wide range of academic and professional studies, end quote. But none of the courses examined involved introductory engineering courses. So, in the summer of 2016, Beer began his study on a 10-week Mechanics of Materials course. His sample consisted of 80 students, 42 took the online course, and 38 learned face-to-face. In terms of gender, the class was 12.5% women and 87.5% male. 26 learners, or 32.5%, were international students. 67.5% were from the U.S. The in-person course was based on the lecture model, while the online course consisted of a mix between lecture videos, which were on average 12 minutes in length, and problem-solving explanation videos. These were put together by the instructor and averaged about 10 minutes in length. Another quality sets this study aside. Beer had a good idea of what academic achievement was supposed to look like on a student-by-student basis. ISU requires a few other introductory engineering courses, one of which is Statics of Engineering. Previous research has shown that statics of engineering grades to strongly correlate with mechanics of materials grades. Beer, therefore, didn't just have a test group to match his control, he had grounds to match them against their previous performance as well. So, before beginning, Beer posed the following questions. 1. How do engineering students' grades compare between students enrolled in an online mechanics of materials course and students enrolled in the traditional lecture format course? 2. How do the different group grades, that's demographics and academic performance, compare between students enrolled in an online mechanics of materials course and students enrolled in the traditional lecture format? So here are the results. Beer found, quote, a statistically significant difference between the grades of the two classes, end quote. In terms of GPA, face-to-face students scored virtually an entire grade point better on average. Online students averaged a 2.0, while face-to-face collectively logged 2.96 for their GPA. This is especially significant because, according to their previous statistics of engineering grades, quote, there was no difference between the academic standing of students who enrolled in the traditional class and the online class, end quote. Beer notes that, quote, international full-time, high academic performing, and low academic performing groups enrolled in the online class had no difference in the mechanics of materials course scores than their traditional counterparts. All other groups academically performed lower in their mechanics of materials course than the corresponding traditional groups, end quote. That's not the news that advocates of online learning would hope for. But there's also a notable point Beer makes. Quote, the discussion raises an interesting question regarding high-scoring students. How are these high-scoring students better equipped for online courses than their lower-scoring counterparts? Intuitively, it could be said that high-scoring students have a better grasp of the subject. It could also be that high-scoring students have better self-regulation, which helped them achieve a high score in statics of engineering as well. Online courses may have helped these students change their learning behavior, which led them to perform better, end quote. The results of the study should be taken with a grain of salt proportional to its sample size. Beer acknowledges this and also writes, quote, since the course was offered during the summer semester, most participants were either working or on an internship. This could have hindered the students in being able to manage their time or devote enough time to the course. Also, the traditional class and the online class had different exams and could have caused biased results, end quote. It's obviously difficult to create a class that successfully promotes earned student achievement in any context. Recreating that online is still a hit or miss process in many cases. Much more work needs to be done before the modality is used with confidence, at least in the context of undergrad engineering courses. Beer concludes by writing that a positive next step would be to look into the qualitative student study habits in addition to quantitative performance indicators. This has been Ed Technically. My name is Henry Kronk and I write for eLearning Inside. If you liked this episode, please rate and review it. If you want to hear more, please subscribe. Also, please keep in mind that this show is available as a video on our YouTube channel and also as a podcast on iTunes, Stitcher, Spotify, and Google Play. The basic content for this video first appeared as an article on eLearning Inside, and if you want to learn more about online courses, technology in the classroom, and EdTech in general, be sure to check out our site. It's updated every day. If you want to get in touch with me, please send an email to henry@elearninginside.com. You can also follow us on Twitter @elearninginside. Thanks for listening.